For this experiment, we'll need samples of sugar. Here's dextrose, which is another word for D-glucose, lactose, sucrose, and then enantiomerically pure fructose, galactose, maltose, and glucose. You'll need some distilled water, some beakers, spatulas, a polarimeter connected to the vernier interface, connected to a PC running Logger Pro. It will automatically open at the polarimeter page. We need to make a 10% mass by volume solution of each of the sugars. So do a calculation and weigh out just enough sugar to make your solution. You'll be making 30 milliliters total for each of these aqueous samples. We're going to calibrate the polarimeter by running pure distilled water. Fill the cell up to the 10 centimeter mark and then place in the polarimeter. The 10 centimeter mark on this sample cell does not equal 10 milliliters. Calibrate the polarimeter by pressing collect on the software and then manually rotating the dial on the polarimeter. This generates a curve in the software. On the calibration curve, identify the point at maximum illumination. You can do that by the human eye, or you can do it with a Gaussian fit using Logger Pro. Record that number. You will need to store this calibration curve by going up to the Experiment tab and clicking Store Latest Run. Switch out the distilled water for your first sugar solution sample. Your 30 milliliter sample should adequately make up that sample cell to 10 centimeters. Put this into the polarimeter sample holder and collect data. Collect sample data by pressing collect on the software and then rotating the dial on the polarimeter. This gives a new trace that is either peaking to the left or peaking to the right of the calibration curve. Record the angle of maximum illumination for this particular sample. This one was D plus glucose. For each sample that is run, it's important that you measure the height of the meniscus in the sample cell holder. This has to be reported in the data sheet. Rinse the sample cell with distilled water and then add about 10 centimeters of height of your next sugar solution. This one is galactose to the sample cell. Record its height, put it into the instrument, and collect new data. Press collect. and record new data on top of your existing data. The next sugar to be analyzed is negative fructose. Just press collect. And you can see now that fructose has a peak that has a maximum to the left of the calibration, whereas galactose and glucose rotated light to the right, fructose rotates light to the left. In total, we recorded 10% mass by volume solutions of galactose, glucose, fructose, maltose, and sucrose. The combined data set looks like this. You can see that most of the sugars rotate a few degrees to the right of the calibration curve, whereas fructose was noticeably different in that it bent light to the left. The combined data table looks like this.